Hi, this is Professor V.K. Patil. I welcome you to my video classes on basic electronics. In my last classes, we have discussed about the different number systems. Today we will see how to convert these numbers from one number system to the other number system. So for that, let us first convert binary to decimal, then octal to decimal, hexadecimal to the decimal. Right? So all the number systems I am converting into the decimal. As we know that decimal number system, binary number system, hexadecimal number system and octal number system, these are positional number system. Their weighted sum, it gives you the decimal equivalent. Let us see with example how to convert a binary number into the decimal. For that, let us consider the example 1010.01011. This is the binary number. I wish to convert this binary number into the decimal number. So the weighted sum in any number system that gives you a decimal equivalent. What do you mean by the weighted sum? So we need to identify the position of each and every digit in the number system. Do its weighted sum, you will get a decimal number. So for this particular example, we have the position. We start the position. We start writing the position from a point. So towards the left of a point, we need to go on increasing the position from 0. Towards the right of point, we need to go on writing from -1, -2, -3 and so on. So here position is 0, 1, 2 and 3. Towards the right we have -1, -2, -3, -4 and -5. Hence its weighted sum can be written as 1, this symbol 1 multiplied by its position, that is 2 raised to 3, because for binary number system we have the radix or the base is 2, hence it should be written as 2 raised to 3, plus the symbol is 0 and its positional value is 2 raised to 2 plus 1 into 2 raised to 1 plus 0 into 2 raised to 0. This is for the integral part, plus again for fractional part 0 into 2 raised to -1 plus 1 into 2 raised to -2 plus 0 into 2 raised to -3 plus 1 into 2 raised to -4 plus 1 into 2 raised to -5. Now its equivalent I need to identify. How do I can identify? 2 raised to 3 is 8, which is multiplied by 1. So this is multiplied by 0. It gets a 0 value. This is also multiplied by a 0. Its value is 0. Here again we have a 0. Here again we have 0. So these all terms they give a 0 result. Now 1 into 2 raised to 1, which comes equal to the 2. Now 1 into 2 raised to -2, which comes equal to 4 raised to -1, that is nothing but 1 by 4, which is equal to 0.25. 1 into 2 raised to -4, which comes equal to 1 divided by 8, and here it is 1 divided by 16. 1 divided by 8 is 8 plus 2 is 10, 8 plus 2 is 10 plus 0.25 plus it is half of this, which is equal to 0.125. It is half of this, which comes equal to 0.0625. Right? 0.0625. And if I add all, you will get its decimal equivalent. So here you will get these values as, so let us perform the addition. 10 plus 0.25 plus 1 0.125 0.0625. Get this as 5 plus 2 is 7, 6 plus 2 is 8, 8 plus 3 is 13, 13 plus 13, the carry with 1, 2 plus 2 is 4, which is equal to 10.4375. This is what the decimal equivalent of this binary number. Is it understood? The decimal equivalent of any binary number is nothing but weighted sum. In other words, if I write the weighted sum in any number system, I will get its decimal equivalent. Now let us see how to convert the octal number into the decimal. How to convert octal number into the decimal. So for that reason, again let us consider the example octal number 765.23. This is the octal number. I wish to convert this octal number into the decimal number. As said earlier, the weighted sum in octal number system, that gives you a decimal number. To write a weighted sum, we need to find the position. This is the position 0, this is position 1, this is position 2, here again position -1 and -2. Now the weighted sum can be written as you will get 7 into 8 raised to 2, because in octal number system we have the base or radix which is equal to 8 raised to its position. The position of symbol 7 is second position, hence it is 8 raised to 2, plus symbol is 6, position is 8, position is 1, hence it is 8 raised to 1, plus 5 into 8 raised to 0, plus 2 into 8 raised to -1, plus 3 into 8 raised to -2. Here you will get the decimal equivalent, which is equal to 7 into 8 into 8, which is equal to 64, plus 6 into 8, which is 48, plus 5 into 8 raised to 0, 8 raised to 0 is 1, 5 into 1, which is equal to 5, plus 2 into 8 raised to -1, which is nothing but 2 divided by 8, plus 3 divided by 64. If you simplify 7 into 64, which comes equal to 448, plus 48 plus 5, 2 by 8, which is equal to 1 by 4, which is equal to 0.25, 3 divided by 64. If you perform the calculator, you will get this result. If I add the result, I will get a decimal equivalent, which is a weighted sum, which comes equal to 501.296875. So I can say that, so octal 765.23, which is equal to 501.296875 decimal. This is how I can convert the octal number into the decimal. Next to this, we will discuss how to convert the hexadecimal number into the decimal. To convert the hexadecimal number into the decimal, again let us consider the example. This is what hexadecimal to decimal conversion. So for that reason, let us say the number FA2.2a. This is the hexadecimal number. I wish to convert it into the decimal. As said earlier, again, the weighted sum in any number, it gives you a decimal equivalent. And to write the weighted sum, we need to identify the position of each and every symbol present in the number. So here we have the hexadecimal point, and towards the left of that I need to start with the 0. The symbol 2, it has a position 0. Symbol A, it has the position 1. symbol F, it has the position 2. Then the symbol 2, which is towards the right of hexadecimal point, it has the position -1. The A, it has the position -2. Now I need to write the weighted sum. So weighted sum, I can write it as F into 16 raised to 2. 16 is the radix of the base in hexadecimal number system, and the symbol F, it has the second position. So therefore it is F into 16 raised to 2 plus A into 16 raised to 1, because A is the symbol in the number which has position 1 and radix of the base is 16, plus 2 into 16 raised to 0 plus 2 into 16 raised to -1 plus A into 16 raised to -2. Let us perform this. We know that F, its decimal equivalent in the number system, which is nothing but a 15. So that is its position. So F is nothing but the 15 into 16 raised to 2 plus A. If I use the counting table, A, it comes at the 10 position, hence it is 10 into 16 raised to 1 plus 2 into 16 raised to 0, which is 1, plus 2 divided by 16 plus A is nothing but the 10 divided by 16 square. Now let us perform this by using the calculator. Now 15 into 16 into 16, 15 into 16 into 16, which comes equal to 3840. The first number it comes 3840 plus 16 into 10, which is equal to 160, plus 2 into 1 is 2, plus 2 divided by 16. So 2 divided by 16, which comes equal to 0.125. Next, 10 divided by 16 square, that is equal to 10 divided by 16, which equals to 0.0390625. Now add these all, you will get the decimal equivalent for the given hexadecimal number. So which is equal to 4002.16406. This is what the decimal equivalent for the example. So such kind of conversions usually you will get into the examination. So today we have discussed how to convert the binary number into the decimal. Then we have discussed how to convert octal number into the decimal, hexadecimal number into the decimal, and in any number system, the weighted sum, it gives you a decimal equivalent for a number. In my next class we will see some more conversions. Thank you.